All right, last one. We have A is parallel to B. That's given. And it's also given to us that angle 2 is congruent to angle 3. And although both of those angles are on yellow parallel lines, they are not connected by a transversal. When we are given that those yellow lines are parallel, we have our 4 angle relationships, but they have to be on the same transversal. So looking at this transversal in green, using the numbered angles, I know that 2 and 4 are supplementary. I also have some congruent angles, some corresponding angles. I have options, and I will go through this proof. I might go through this proof more than one way, but the first way I'm going to go through it is using the numbers that they gave me. And so they're giving me angle 4 based on the green transversal and yellow parallels. 2 and 4 have to be supplementary. Then they tell me that 2 is the same as 3. So if 2 is supplementary to 4 and 2 is the same as 3, I could conclude that 3 is supplementary to 4. And that is helpful because when I'm looking at these green lines trying to prove that they are parallel, 3 and 4 are same side interiors. So that is my first method that I'm going to go through to do this proof. So I'm going to start with my given. A is parallel to B. And for this video, I am just going to verbally give the reasons. If you check the key to the notes online, you'll see them filled in, but it's just going to be a little bit too messy and too crowded if I try to write them all myself. A is parallel to B is given. From that, I used the fact that angle 2 and angle 4 are supplementary. Now my goal is to get 3 and 4 supplementary so that I can get my green lines parallel. But we cannot substitute a 3 into this because this is a sentence, not an equation. We can't substitute unless we turn this into an equation, like measure of angle 2 plus measure of angle 4 equals 180 degrees. To turn it into an equation from our pink sheets, our reason is supplementary angles are 2 angles whose sum is 180 degrees. Now, my goal is to get a 3 right here. So in my next branch of the proof, I'm going to say angle 2 is congruent to angle 3, which tells me the measure of angle 2 is equal to the measure of angle 3. And we convert that using congruent angles, our angles with equal measure. That box is my ticket to replacing measure of angle 2 with measure of angle 3. So now we have the measure of angle 3 plus measure of angle 4 is 180. Because I'm replacing, my reason is substitution. Now to get parallel lines, I need to say that those angles are supplementary. So I'm going to get that out of the equation and switch it back to a sentence. Angle 3 and angle 4 are supplementary. And our reason here is supplementary angles are 2 angles whose sum is 180 degrees. And we actually already wrote that once up here. So we could put a Roman numeral 1 and just reference it by saying reason 1. Now that I have those are supplementary, I'm set to say C is parallel to D. And my reason, if 2 lines are cut by a transversal such that same side interior angles are supplementary, then they're parallel. And we're done. Now this one I think could be a little bit tricky to see. And you really do have to be very careful because I could kind of have given you the same question, but instead of giving you the yellow parallel lines, prove green, I could have given the green parallel lines and then asked you to prove the yellow. So this is just one way to do this proof. And now we're going to take a look at a second way to do this proof without using the angles that they numbered. So a second way to do this proof, which is kind of cool. Sometimes it's worth it to take an extra 2 or 3 minutes looking at the diagram. I have that A is parallel to B. So here's method 1. Method 2. A is parallel to B. Given. That tells me angle 2 is congruent to angle 5. We are allowed to add numbers to a diagram. We didn't need to. We saw that we didn't need to, but we're allowed to. 2 is congruent to 5 based on the yellow lines being parallel. We cannot say 2 is congruent to 1. That would be based on the green. 2 is congruent to 5. And a reason is if parallel lines are cut by a transversal, then corresponding angles are congruent. We were given that angle 2 was congruent to angle 3. If we pair these facts, we get that angle 5 is congruent to angle 3. And if we look at 5 and 3, those are alternate interior angles for the green lines. So that takes me directly to C is parallel to D. We don't have to mess with any of that algebra. We don't have to substitute. It's a shorter proof, maybe a little harder to see because the angles aren't numbered. But if 2 lines are cut by a transversal such that alternate interior angles are congruent, then they are parallel. These are not the only 2 ways to do these proofs, but this is 2 sample solutions that would both work for this question.